Oh, hey. Sorry, I didn't see you there. I was too busy checking myself out in this mirror. How about that? Today in class, what we're going to be talking about is we're going to be talking about reflection and flat mirrors, such as this one right here. Flat mirror just being a mirror that is naturally flat. And reflections and how they work. So here are the main kind of goals that I want you guys to take away. You guys can check those out. This sheet is going to be posted. This is going to be what you guys are working through today. Is this kind of little sheet. It's got some guided questions. It's got some additional videos and interactives I'm going to have you guys mess around with. So hopefully by the end of the day, you guys will feel comfortable with these questions and with these ideas. So the first thing that we're going to talk about and that I want to talk about in this video is just looking at reflection and the ray model of light. And I want to get a little bit of vocabulary with that. So as we mentioned the other day, we have this ray model of light, which is essentially instead of modeling light as a wave, where we're focused on wavelength, frequency, speed, energy, direction, and all of that, it's a more complete model of how light waves actually work. But when we're talking about reflection or refraction, or how waves just kind of travel through space and interact with surfaces and how they can bounce off or travel through, the only thing that we're really concerned about with that is direction. Right? In what direction are they headed? Right? What way are they coming in? What way are they leaving? Okay. So we actually use the ray model of light to talk about this. So we don't worry about the wavelength, the frequency, the energy, any of that stuff. We're just concerned with direction. And light will always travel in a straight line in a particular direction. Now, one thing to keep in mind is that rays of light leave a source in all directions. So for example, if I had a light bulb here, like this, right? There are light waves, which we can model as rays, leaving this in all directions, right? Every single direction. The only and they're kind of moving through the glass and out into space, right? Where they interact with those surfaces, they're either absorbed by those surfaces, or they're reflected off those surfaces, or they transmit through those surfaces. So one thing that's interesting is if you look at this, there's light waves being sent backwards into the light bulb, but they kind of get reflected or absorbed by the metal and the other materials in here. So it can kind of focus the light outwards in this way and not through the base. Now, a more extreme example of that is if we look at like a flashlight, for example, if you guys can see this, inside of here there's a little light inside of there, and around it is this reflective kind of cone that makes it so that the light is shot outwards more, right? So it's a more directed beam of light where it's going, right? It's more directed, so you can get a nice little beam, right? It shows up as a nice little kind of like dot there, right? So that's that. So that's the ray model light. That's what we can use. Now, when light is traveling and it's moving out, it can either be reflected, absorbed, or transmitted, as we've talked about. Today we're going to be focusing on reflection. And I want to stress again that there's two different types of reflection that we can have. You can either have this, what's called specular reflection, which you get off of very flat, smooth surfaces, or you can have diffuse reflection, which is where we have these slightly bumpier, rougher surfaces. Now there's a few rules that we're going to talk about and that you guys are going to explore. It's called the law of reflection, which talks about how light waves come in and come off of a surface when they're reflected, right? There's actually a very particular way that they do that has to do with the kind of geometry and the angle at which they're coming in and the angle at which they leave, right? Called the incident angle and the angle of reflection. There's this normal line, there's the surface itself. So you'll notice this here, it's a smooth surface. This one, it's relatively flat, right? So as they come in, they're going to bounce off in all sorts of different directions. They're going to scatter all over the place. Now to kind of illustrate the difference between those two, I'm actually going to use my little mirror here, right, and my flashlight to talk about what's actually happening. So if I have a flashlight, and let's do it on this side first, on this just wooden side of my mirror, right, which is just straight wood. If I shine this light on there, you'll notice, right, the light is bouncing off of the wood and bouncing into the camera that's recording this video. Now, regardless of where I move the light source, right, and the angle at which the light is coming in, right, there's still a good bit of light that's reaching the camera. And that's because this light is reflecting the wood surface is relatively rough, and so there's light reflecting off into all directions from all directions into the camera itself. Now if I flip it over and I use the mirrored side, right, like this, you guys can kind of see that. If I use the mirrored side and I shine it like this, right, you can see it lights up the mirror a little bit, mostly around the edges, not around the center. It's not perfectly flat, it's got this kind of cavity, right? But only when it's at a particular angle does it fully get picked up by the camera. See there, you can actually see the light itself, and you'll see how bright it is. Most of that light is reflecting straight into the camera, right, off of the mirror, right, and you can actually see it. But at all the other angles, you can't actually really see that light source. And that's the difference between a mirror, which is a specular reflection, and diffuse reflection, right? Diffuse, it's bright no matter what the angle is. It maintains about the same brightness because it's bouncing off in all directions. But with the specular, right, only at certain angles are you actually able to see the full brightness, right? And that's the difference between specular and diffuse, really, is that if specular, if I have a bunch of light waves coming in, at one angle, they're all going to come out at the same angle, right? Whereas with diffuse, because of the rough surface, if I have a bunch of light waves coming in at one angle, they're all going to come out at different angles, and so they're going to scatter more into all sorts of different directions. Now, this isn't necessarily just with mirrors or other things. A lot of surfaces are diffuse. In fact, most surfaces that you look at, most things that you can kind of see clearly, and objects that have like a shape, are this diffuse reflection. So for example, here I have a little object, this little vase with some fake little flowers. And these fake flowers are very diffuse, right? They're a relatively rough surface. You can kind of see their reddish color, the greenish leaves, but you know, there's no like shininess, right? A sign of specular reflection is kind of this shininess, or you can see an image, right? Whereas if I look at this pot, right, you can actually see a reflected image, which means that this pot is relatively smooth. We're getting more of a specular reflection. Now, it's not as good as a mirror, right, but it's still a lot smoother reflection, right? We're getting more of that clear image that's bouncing off, okay? So like I said, a lot of things are diffuse, a lot of objects that we see, but anytime that you see like a glare or a shine or a mirror image of something, then we know that we're getting more of a specular reflection. A good example of specular reflection that you guys will see out in nature, a nice smooth surface, is if you guys had like a lake, for example, or a still body of water, right? Very, very smooth surface. Water kind of fills in areas and becomes a nice smooth flat surface, and it reflects images very, very well. Now, one thing to note, and we'll talk about this today as well, and you guys will explore this, is that here we have a reflection. We'd call it a mirror image, right? And one thing of note is that there is no mountain down here, right? This is not the mountain. This is what we'd call the image. Whereas up here, we actually have the object, the mountain, right? So light is coming in from the sun. It's reflecting off the mountain, relatively diffuse in a lot of directions. Some of those light waves come to the camera, so you can see that the mountain is here. Some of the light waves go down to the pond, bounce off the pond, and then come to the camera. So it appears that the mountain is also here as well, right? So this is what we'd call a nice example of specular deflection. Now, if you ever see a pond and it's really like windy or something, or really choppy, then you will get less of this smooth surface. It'll be a little rougher, and you'll get more of a diffuse reflection. You won't be able to see the mountain as clearly as when it's a nice smooth surface, okay? So that's talking about kind of reflection. We got specular and we have diffuse. And I'd like you guys to research some other images. It's nice to see some visuals on that. The next thing I'm going to have you guys do is check out this interactive from the physics classroom. And this talks about, this first piece is the law of reflection, which defines how light waves enter and exit when they're reflecting off of a medium. So there's some vocabulary I'd like you guys to know there. And then there's a second part of this that talks about mirror images and how they form. It's a pretty good example of that. There's a few things I want you guys to pay attention of as these images form. What are some patterns that you notice with how the images actually form? And that tutorial is here. It kind of looks like this. You can use this corner and make it bigger or smaller as you guys see fit. And then this last piece, I'm going to post one more video kind of talking about flat mirrors that you guys might see in your bathroom, for example, and about how that kind of works and some of the geometry and stuff that's going on there. So be ready for that. There's a few readings is the last piece I'd like you guys to check out. And then I'm going to post an answer key to these questions if you guys would like to check your work. So that's what's coming on, and I will see you guys later.